This is Algebra 2, Lesson 3.2, and we are going to be doing Part 1 of solving systems algebraically, and we're going to learn the substitution method. So I'd like you to pause the video and write down these steps. Step 1, solve one equation for one of the variables. Step 2, substitute the expression into the second equation and solve. And Step 3, substitute the known value into one of the equations and solve for the other. Okay, the first step in solving this equation using the substitution method is to pick a variable that we're going to solve for. So that's step 1. We're going to solve for a variable. Now what I want you to notice is that y is by itself right here. So what we're going to do is we're going to solve that equation for y. So I'm going to move my x term to the right, so that y equals negative 2x plus 10. So that's step 1, solving for y. Step 2 is to take that and substitute it into the other equation. So the top equation up here, the 3x plus 4y equals 12, is the one I'm going to substitute into. So since y is equal to negative 2x plus 10, I'm going to come over here and plug it in for y in my other equation. Okay, so y now has turned into negative 2x plus 10 from my other equation. Now that I have my substitution done, we're going to take and solve this equation. So we're first going to distribute. So 4 times negative 2x is negative 8x, and 4 times 10 is 40. I'm going to carry everything else down. I'm going to combine my like terms. Subtract my constant term over to the other constant. And then divide by negative 5. So we get an x value, my negatives will cancel, of 28/5. Okay, so that is step 2. This all over here was step 2. Step 3 is to take our answer from step 2 and to plug it into one of our original equations. Now I like to work with the equation that has smaller numbers, so I'm going to start with that second equation, and I'm going to plug in my x. So since x is 28/5, I'm going to plug it in right there. And then I'm going to solve. So 2 times 28 is 56/5. And 56/5 is 11 1/5. Then I'm going to subtract it to the other side. And y equals negative 1 1/5. Okay, so when we solve systems of equations, we always get an ordered pair as its answer. So in my parentheses here, I'm going to start with my 28/5, and that's my x value. And my y value was negative 1 1/5. So you're probably wondering, well, why would we go through all of this work when we could just graph it? Well, what you're probably seeing now is that we get fractional answers sometimes as solutions, and it's really hard to know exactly what the values are when we graph it. So algebraically gives us guaranteed every time the correct solution. Let's do another example. First, I want you to think about what variable are you going to isolate? Which variable is by itself? Well, in my first equation, x is by itself. So I'm going to solve for x. So I want to get x by itself, so I'm going to subtract this y term over. So x equals negative 3y plus 5. So that's step 1. Step 2. We're going to take the other equation, which in this case was the bottom equation, and we're going to substitute in for x. So since x equals negative 3y plus 5, I'm going to plug that in for x. So I have my negative 2, plugging in my negative 3y plus 5. And now I have an equation that just involves y. And that's helpful to me so that I can solve. So negative 2 times negative 3 as I distribute is 6y. And negative 2 times 5 is negative 10. Carry everything else down. I'm going to do like terms. Add 10 to both sides. 2y equals 5. Divide by 2. And y equals 2.5. Alright, so in my solution, the y-coordinate in this case is 2.5. And then I'm going to go back to my equations, and actually I can go back into this rewritten equation and plug in 2.5. So negative 3 times 2.5 plus 5 is negative 7.5 plus 5, which is negative 2.5. So the solution for x is negative 2.5. So our solution is negative 2.5, 2.5. All right, one more example before we're finished here. Negative 3x plus y equals negative 5 with the equation 3x minus y equals 5. So we're going to isolate a variable, and I'm going to choose to isolate this y. So I'm starting with that equation. So I'm going to add my 3x over. So y equals 3x minus 5. And then I'm going to substitute that into my other equation. So since this is y, I'm going to plug it in right there. So I have 3x, and I'm subtracting the 3x minus 5, which is now y, equals 5. So in doing that, there's actually a 1 here that we're going to have to distribute, a negative 1. A negative 1 times negative 3, and a negative 1 times negative 5 is positive 5. Now 3x minus 3x is 0. And 5 is equal to 5. So notice how the variable dropped out, and because that has happened, we end up with a true solution, a true statement, which means that this is consistent. And since 5 equals 5 and there's no variable, we say it's independent, which means there's many solutions. If we were to get a false statement, then there would be no solution and it would be inconsistent. All right, that is it for solving algebraic systems with substitution.